Hello, you're welcome to class. Today we are going to be answering some questions on set language and notation. Now, the very first question here is find the universal set where it is the set of all x's such that x is a natural number less than or equal to 16. I'll read that again. Remember, this notation represents universal set. And our universal set is given by the set of all x's such that x is a natural number less than or equal to 16. Remember, your natural numbers and counting numbers. The very first counting number is 1. So we are going to list the elements of our set now. Our set comprises 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All right, now write down all the square numbers in your universal set. Our square numbers here would be the very first square number. Please remember 1 is also a square number. So our square numbers are 1, 4, 9, and 16. So we're going to write them down. 1, 4, 9, and 16. Write down the prime numbers in the universal set. Remember, prime numbers are numbers that have only two factors, 1 and their cells. So the very first prime number, which happens to be the only even prime number, is 2. Up next, we have 3, 5, 7, 11, and 13. Please remember that 9 isn't a prime number. Okay, so the prime numbers in this particular universal set are 2, 3, 5, 7, 11, and 13. Moving on, this is question C, and it's saying that we now have a subset within our universal set. This subset is a set of all, subset M is a set of all x's such that x is a multiple of 3. So we need to go back to our universal set and look out for the multiples of 3 within that set. Now, the multiples of 3 within that set, remember the very first multiple of any number is the number itself. So the first multiple of 3 will be 3. Next, 6, 9, 12, and finally 15. Also, we have the set of F. F is the set of x, that is the set of numbers within our universal set, such that x is a factor of 15. The factors of a number, the very first factor of any number is 1. And please, when you want to write down your factors of numbers, I would advise you write them in pairs. By factor pairs, I mean numbers that you multiply together to give you the original number. So for 15, the factor pairs will be 1 and 15. And 3 and 5. So those are our factor pairs of 15. All right. So now that we have identified our subset, we are going to complete the Venn diagram given this particular information. Now, when you are asked to complete a Venn diagram, the very first place you should attempt to fill up is your intersection. By intersection, I mean this space, the overlap between the sets. Now, since we have just two subsets here, so we are going to be filling this particular overlap. This particular overlap will consist of numbers that show up in both set M and set F. The very first number that shows up in set M and F is 3. So we're going to write down 3 here. Another number that shows up in both sets is 15. We have filled up our overlap, our intersection. Then you go on to the individual set and look at them. What numbers are within the set when it was listed here but do not show up in the Venn diagram? Here we have 3 represented, 6. We do not have 6, so we're going to write down our 6 here. So 6 is a member of set M, but it is not in the intersection of M and F. That's why we are writing it here. Same thing for 12. We're going to write our 12 right here. All right. Now, before you move on, please do a quick check to confirm that you have represented all the members of set M in the circle representing set M in the universal set. So I have 3, 6, 9, 12, 15, 3, 6, 9, 12, 15. I'm good to go. Then I move over to set F. Set F is the set of the factors of 15. All right. So 15 has 4 factors: 1, 3, 5, 15. I checked the numbers I have already. I have 1, 3, 15. So I'm missing 5. So I'm going to write my 5 right here. Okay. So now the 2 circles are complete, but we're not done yet. Remember, in your Venn diagram, the rectangle represents the universal set. So all the numbers that show up in our universal set should also show up within our rectangle. Most of the work has been done. We just need to do a quick check and see the other numbers that are still missing. So I have 1, 2, 3. So I don't have 4. That means I need to put 4 out here. 5, 6, 7, 8, 9, 10 is missing. 11, 12, 13, 14 is also missing. 15 and finally 16. So all the numbers have been accounted for. All numbers within the universal set, when we listed it, have been represented in the Venn diagram. Up next, we have write down all the odd numbers that are not in set M and not in set F. Your Venn diagram should help with this. If a number is not in set M and not in set F, that means it is out here. So what are the odd numbers that are out here? The first one I see is 7. Then I see 11. And also I see 13. So those are the odd numbers that are not in set M and they are not in set F. Okay, find the number of elements in M intersection F. That's how to read that statement. This is talking about the cardinality, the number of elements in set M intersection F. Okay, now this is the region representing M intersection F. This region here, this overlap region here. So since this is the region representing M intersection F, you need to count the number of elements there. How many elements do we have there? We have 2 of them, 3 and 15. So our answer here will be 2. We have 2 elements in the region M intersection F. Okay. A number is chosen at random from the universal set. Find the probability that this number is in set F. Now, the universal set consists of 16 numbers, numbers 1 all the way to 16. How many numbers are in set F? We have 4 numbers in set F. So, this question will be answered as we have 4 numbers in set F out of the possible 16 numbers in the entire set. You could take this to the lowest term or leave it like this. You're fine either way. So this would also be written as 1/4. Thank you for watching. I hope you understand what we have looked at today. If you have any questions, feel free to please comment or send me a message. Thank you and see you in the next one. Bye.